That quote is actually quite applicable since I've been working on substantially the same idea for something like 6 years now. And I keep telling myself I'll kind of ease off a little bit. I always seem like there's one more thing that I need to do, and I do that, and there's another one more thing, so I'll probably be at this till I die. Hello, I'm David Schwartz, the Chief Technology Officer at Ripple. I kind of want to start at the end to let you know where I'm going so that, number one, I don't forget to make the whole point that I came here to make, but also so you kind of know where I'm going and you can kind of assemble the ideas in sort of a framework. So there's been a revolution. Most of you are probably too young to remember the days when data was circuit switched. When you made a phone call, it was on a circuit that's held for the whole call. And there was a revolution, the internet, that switched from circuit switch data to packet switch data. And that made it much more interesting to interact with information. In the telephony age, there wasn't much you could do with information. You could just switch it from point to point, or you could be the endpoint. But there wasn't a sort of rich ecosystem of data services. And obviously, as I'm sure you all know, today the internet has an incredibly rich ecosystem that developers participate in by interacting with data in a much more complex way than you could in the circuit-switched era. And while that revolution was dramatic, it was not unprecedented. There was actually a similar revolution in the physical delivery of goods. You don't have to go back too many years before it wasn't possible for me as a consumer to order something from China and get a packet, a week later for, on the order of $5. And the elements of commerce are the physical delivery of goods, the exchange of information, and payment. And we have not had that revolution in payments yet. And the point that I'm going to make today is that we are sort of in the pre-shipping container circuit switch days of payments, and we're going to be in the sort of standardized ecosystem world of payments where you can interact with payments in incredibly flexible and powerful ways. And that's going to be a tremendous opportunity for developers to be able to sort of complete that triangle of the physical delivery of goods, the exchange of information, and the movement of money. If I can't pay you for a service, there's really not as much point in you providing it to me. And if we can complete that triangle, that's when we'll really see an explosion. So that's kind of the argument that I'm going to make today. And I'm going to show you what payments might look like in the future and where we are in the process of modernizing them today. So I work for a company called Ripple. I was the second employee in late 2011. We have more than 300 employees. And we are an enterprise blockchain payment company focused primarily on international payments. We have more than 200 customers that are our companies that are our customers. They're financial institutions, mostly payment companies and banks. And what we're trying to get to is what we call the Internet of Value, which is this idea that we would be able to move information, move value as easily as we move information. So that's why we call it a sort of Internet of Value. The Internet today is this flexible exchange of information. And we want all of the properties of the internet, or at least all of the interesting ones. So like I get an internet service provider, and I don't have to do anything with what websites I want to use. They just work. And I don't have to care about what internet service provider or website uses. And the internet service providers don't advertise to me by saying we have all the best websites. You can interact with all the best stuff on our network. What they tell me is that they have good cost, they have good service, they have good performance for me. And we want the same thing. We want sort of local services to be able to offer access to money that are targeted at various different markets, but where you have full interoperability. And that's kind of where we see the world going. But as a business, like having a day-to-day operation, it's very hard to talk about a vision. So we kind of have something a little bit more specific, which is to reduce friction from global payments. Why global payments? Because they're the worst. Domestic payments generally work pretty well. Most people in this room, if I asked you, like, have you had good experience with domestic payments, you'd probably say, yeah, they're fine. But if anyone who makes international payments will tell you that the experience degrades very, very rapidly. And there are some fundamental reasons for that I'll talk about a little bit later. So that's the low-hanging fruit. That's what we can fix. That's where the absence of standardization is the biggest problem. Domestic payments generally are standardized. International payments are a terrible assortment. So So how did we get here? What's the technology that sort of opened the floodgates to this revolution? It was blockchain. And I like this analogy that the way the internet works is that computers provide information to each other, and you just sort of take that information as valuable because you got it from a useful source, we would hope. You know, if your uncle who forwards every garbage article, you get it from him, you say, well, that's a bad source, so I'm going to ignore that information. But if it's your bank or an airline or your boss who sent you an email or a message, the reliability comes from the source. That's not how blockchain works. The way blockchain works, it is not possible to lie. Every piece of information is checked for compliance with all system rules by everyone who receives it. And that is the secret sauce of blockchain. Imagine if when I went to my bank, instead of them just giving me a balance, instead of saying you have 32,000 euros or you have $53 or whatever, they actually had to prove to me, hey, we told you your balance was 43 euros, and we're telling you it's 41 euros today. And the only way they could do that is by showing me an authorization for a payment. If there was literally no other way they could tell me a lower balance than showing me an authorization for payment, then I could trust that information no matter who I got it from. Whoever tells me I authorized a payment, I authorized a payment. We use digital signatures and cryptographic algorithms to secure those systems, and we allow every participant in the system to enforce all the system's rules. That's what's new. That's what allows us to interact without the kind of trust that financial systems have traditionally had. So what is a blockchain? Well, Bitcoin was the first blockchain. Satoshi Nakamoto didn't discover unobtainium or vibranium or some secret thing that nobody had before. What it was a clever combination of existing technologies. And this is not atypical of the way we have innovation. I'm going to talk about the Model T a little bit later, and it's the same thing. There was no single major technological breakthrough in the Model T. It was just a clever combination of a number of things. Breakthroughs just in gearing systems, breakthroughs in material science to be able to produce rubber materials that could produce the tires. Just every bit of it was just different technologies assembled together. And the Model T was not a great vehicle, but if you were clever, you could say, hey, maintenance is not good on the Model T, but there's no reason automobiles have to have maintenance problems. There's no reason they have to be limited in speed, or none of the limitations of the technology were fundamental. It was clear that they could all be fixed. And if you have that kind of vision, you could look at the Model T and say, the horse is doomed. Now, of course, it's hard to do that. Easier in retrospect to say we should have seen it. But that's the thing. It's a combination of technologies. And the key one is this aspect of validation, this idea that all of the system's rules are known and enforced by all participants. So we can trust blockchains because they don't have system administrative functions. All state and rules are public, and all participants can enforce the rules. So you can independently verify every piece of information that passes through the system. And if anybody lies to you or gives you incorrect information, it's just as if they didn't speak at all. You literally enforce every system rule. And I think while Bitcoin was the first technology to come on the scene, there's now kind of been a diversification. Just like nobody here, I assume, drives a Model T, what we have is we have diversification for different use cases. We have trucks for hauling goods. We have sports cars for luxury and comfort. We see a focus on different use cases. And also we see limitations in the technology that are not fundamental, that are just, you couldn't build a perfect car the first time. You kind of need some experience. Those kinds of things get improved. And we've been looking at the use case for blockchains. And you probably hear people talk about using blockchains to track the freshness of avocados or the provenance of goods. And it's not that those are bad use cases. There are lots of interesting use cases for blockchain. But most of them come back to payments. Most of the interesting ones, where trustlessness matters, is where money is involved. If I'm trusting you, it's generally either about money or something very personal, but the ones that sort of scale are money. And if I'm lending you money, there's a payment, and you're paying me back. If we're settling a stock trade, I'm buying the stock. There's money. There's not just the movement of the stock. And if you go down all of the interesting use cases where these technologies are valuable, there's a payment in there somewhere. So we have to get payments right. If we don't get payments right, none of this other stuff matters. So why aren't payments right? Why don't we have them? Payment networks are disconnected. We don't have that internet of value. What we have are these independent systems that don't talk to each other. And that creates real problems. Payments are slow. They take 3 to 5 days. And that means generally that people have to pre-fund and put money where they think they're going to need it 3 to 5 days from now, which is pretty irritating. That's very costly. There's trillions of dollars sitting in accounts just waiting to make domestic payments for people who don't want to handle an international payment. So for example, you look at a company like Seagate, and they have a supplier in Thailand they might need to pay. They generally will handle that by having Thai bots sitting at a bank in Thailand so they can make a domestic payment anytime they need. But they'd rather not have their money sitting around. They have a high cost of capital. They'd rather someone else's money be sitting there. And yet there's no way to really make that happen. And they're unreliable. About 6% of payments fail. The number one reason is the information needed at the recipient wasn't included in the payment in the first place because we don't have closed-loop messaging. It's kind of idiotic, but we push our payments into the void and hope they get to their destination, and if they don't, we kind of hope they come back. And even for the payments that succeed, it's not unusual for people to call up their bank to ask if the payment succeeded, and the bank doesn't know. So they'll tell you to check with the recipient and call back in a couple of days. It's an extremely inefficient system. And that doesn't work for things that people want to do with payments today. So what doesn't it work for? Imagine if you're a Seagate or an Amazon or an Airbnb or an Uber. These companies all make large numbers of small payments. Amazon has thousands of merchants that they make payments to. Uber, if you're in the Philippines and you're a driver and you need money for milk, Uber would love you to drive for them and buy milk right that day. But they need efficient payments. They need payments that are as reliable as email for that to happen. And that doesn't exist. And each of these companies employs literally hundreds of people just in their payment division. And if you imagine if you ran a payment company, you would love to go to any of these new corporates and say, hey, fire your hundreds of payment people, we'll do all your payments. But there's nobody who can do that. And so if you imagine if I want to start a regional competitor to Airbnb, let's say I want to do Airbnb just in the Boston area, but I want to take incoming payments from all around the world. The solution can't be that I hire 100 payment engineers to make that business work. That can't be the right solution. So this is going to change. This is broken, and someone is going to fix it, and this is a tremendous opportunity. So I'm sure you've all heard about digital assets and blockchains, and I think a lot of people got into that field because they thought that digital assets and blockchains would solve the payment problem. So what are digital assets? They're symbols of value that exist only in distributed ledger systems. They exist in these systems that minimize trust and that have this property that anybody can verify the system's rules. They're decentralized. They don't have central operators. They don't have administrative functions. People often ask what Bitcoin is backed by. It isn't really backed by anything. Normally, what you care about when you talk about what something is backed by is what ensures its scarcity. If you ask me what gold was backed by, I would argue that what you really want to know is how do I know that there won't be lots more gold entering the market suddenly and the value of gold will plummet. And what does that for these digital assets are cryptographic algorithms. And it's done in a very weird way. Like, we're not going to discover a new integer between 1 and 5, right? You know, like there are only so many integers between 1 and 5. The definition of an integer between 1 and 5 can only be satisfied in a very obviously countable number of ways. And we actually do that same thing with digital assets. The definition of a Bitcoin or the definition of an XRP is a chain that you can follow. And if I have a Bitcoin, I'm at the endpoint of that chain, and when I transfer it to someone else, I add a new link to the chain. And the number of chains that can meet that definition are limited for the same reason the integers are limited. So it's actually the definitions and the mathematical algorithms that guarantee the scarcity. Now, it doesn't guarantee their value, right? Like, my used tissues are scarce, right? I can only sneeze so many times. That doesn't mean that they're going to have any particular value. And nor does backing necessarily guarantee that something will have a particular value. But it does guarantee scarcity. So unfortunately, there is one thing we cannot do, this beautiful way of having everybody verify everything. There's one ugliness that we can't quite fix, and that's called the double spend problem. And the double spend problem exists because if I can write checks, and I have $50 in my bank account, I could write a check for $50 to Alice and a check for $50 to Bill. Nothing about writing a check to Alice somehow stops me from writing a check to Bill. And if both of those checks are accepted as valid, we have a problem. We've lost scarcity. If I can just, have $50 and write 500 checks. And we can't solve the double spend problem by checking rules because each of those payments alone is valid. What we need to do is we need to agree on an ordering. If we can agree that the payment to Alice comes first, then I'm broke when it comes to the payment to Bill, and vice versa. So we need to solve the double spend problem with something beyond just checking the validity of rules. Bitcoin uses proof of work, or mining. Ethereum also uses proof of work, although they're transitioning to proof of stake because of some of the cost and security issues with proof of work. When I and others designed the XRP ledger starting in 2011, the first thing we said is we didn't want proof of work. And we came up with it's technically a form of federated Byzantine agreement that we call consensus that's faster and cheaper than proof of work. And the result is that XRP is a decentralized digital asset not connected to any jurisdiction that moves more quickly and more cheaply than Bitcoin. And I would argue that it's also more censorship resistant and has some of the decentralization properties that we want. And that's resulted in low cost, low fees, and high transaction time, and transaction volume with low latency. Currently, there are several companies building on top of the XRP ledger. It's completely open. You don't need anyone's permission. You can download the software. Nobody controls it. There are no administrative functions. I'm going to talk more about Coil, though, because Coil is a web monetization provider. And this is a very interesting thing, and I will come back to it. But one of the things that doesn't work well today is monetization of content. Today, there's two models, advertisement and subscription, and they're both terrible. Problem with advertisement is it's an arms race. Everybody hates advertisements. It's what's driving the loss of privacy, because if you come to my website, how much money I can make off you depends on how much we know about you. If I know where you live, your sexual orientation, whether you're married or single, how much money you have, whether you like boating or not, I can target an ad to you that's worth more money than if I just know you're a person. And so the driver of reducing privacy is broken content monetization. The other problem with content monetization, the only other way to do it is subscription, and it gets really awkward. It's very difficult to subscribe to every website that you might want to go to. Now imagine if we had an open imagine if money could move the same way email does. A website could have a tag in it that says, here's the address to pay to. And your browser could have a plugin that just streams money to the websites you go to as you go to them. And then instead, when you go to Wikipedia, instead of seeing please donate, you could see thank you for donating. Or when you go to somebody's website that has like a member area, you would just go right into that sort of premium experience. Or you just wouldn't see ads. And this doesn't require any contract or agreement between the website and the monetization provider. Just like I don't have to have any agreement with you to send you an email, I just need your email address. Coil made over 1 billion payments last year, with the average payment being something like 1,000th or a 10,000th of a penny. So this is here and working today. That protocol exists today and works today. So digital assets, can they fix payments? The answer is no. Payment networks are disconnected. Global payments suck. Customers want better payments. Blockchain doesn't solve the problem. So in the early days of blockchain, I'll admit it, I thought this way, a lot of other people did. We thought blockchain would solve the payment problems. Everybody would use Bitcoin for everything. Today, we have something like 1,500 digital assets, and most of them don't interoperate with each other. So not only did we not solve any of the existing payment problems, but we created a newer, sexier version of the same problem, which is that blockchains don't talk to each other. So what we need is a protocol that will move value the way IP moves information. We need an inner network for payments that interconnects everything. And that, I think, will be interledger, which is a completely open protocol, open source implementations endorsed by hundreds of companies and individuals that moves value the same way IP moves information. Now, I think everybody understands this stack. This is the stack that made the internet work. And if I just showed you IP alone, and I didn't show you this slide or this stack, if I just told you all about IP, you would probably say, so what? And justifiably so. But what makes IP so useful is this stack. So let's look below IP. We had Wi-Fi. We had really slow Wi-Fi, 11 megabits. We had 5 gigahertz. We have newer, faster Wi-Fi. IP didn't change. We have fiber, we have Ethernet, we have 3G, 4G, 5G, LTE, all these technologies. IP didn't change. We had tremendous innovation underneath IP, making the internet faster. IP stayed the same. And we had tremendous innovation on the top, too. HTTP didn't exist. Torrents didn't exist. All of these higher level protocols, streaming media, none of these things existed when IP was created, and IP did not have to change to support them. What happened is IP became this really dumb way to move really small amounts of data unreliably. Like if I was like the negative case for IP and you didn't see the stack, I'd say, it's not reliable. It can't move a large chunk of information. You know, it doesn't have a circuit that guarantees that like it won't deliver out of order. It sounds terrible, but what happens is because of this innovation above and below it, and because it's so neutral, it doesn't lock in a whole bunch of decisions that really steer you in any particular direction, it was able to fuel the revolution in information. This is the interledger stack. In the middle is ILP, and just like IP, it just carries value between networks. That's literally all it does. It's just a packet that comes in with value in dollars and maybe goes out with value in euros or bitcoins or whatever. It's really ridiculously simple. It's just a source, a destination, the value. It's maybe not quite literally, like, you know, obviously if IP has a don't fragment bit and it has ICMP and all, you know, it's not literally that simple, but conceptually, it's really, really simple to route and switch. And below it, we have where the actual value is. That could be blockchains. That could be scaling protocols like Lightning. Could be banks. Interledger doesn't care where the money is, just like IP doesn't care what network the data flows over. And above it, we have complex payment protocols. Now, you might think, how do I do a complex protocol with a micropayment or a light payment system? The same way that you do complicated things on top of IP. You build layers. You build TCP on top of it, handle the reliability and the ordering. And you build maybe HTTP on top of that. And maybe you have sessions and you have cookies. And you build the intelligence at the endpoints. And you keep the middle really simple and dumb. And you do that so that you don't need to constantly keep upgrading the middle to upgrade the endpoints and to do different things with it. And that's what interledger does. So coming back to what I was saying about micropayments, people ask, what would you use micropayments for? And we give dumb answers. Web monetization is a really good one. But other than that, you say things like, oh, my phone could buy Wi-Fi as it needs it. Oh, I could pay to go through a revolving door. Those are all dumb. But if in the 90s you asked me what people would use electronic mail for, I would have given you bad answers too. Or what they would use streaming video, I wouldn't have told you cat videos. Like, I don't know what people are going to use micropayments for. What would you use this packet of data for? You don't use a packet of data for anything. You assemble packets of data into bigger, complex things. So this is the thing. You can make a $1,000 payment with a large number of micropayments, and there are tremendous advantages to doing things that way. For one thing, let's say I want to make a payment. Let's say I want to make a payment. I want to deliver euros, and I want to use dollars, and it's 1,000 euros. Today, I would want a quote. I wouldn't just want to say, hey, here's some dollars, like deliver some euros. I want a quote. I want to know how many euros are going to be delivered. Do I get that quote for free, or do I pay for it? If I get a free quote, it's going to have to be a terrible quote because I might take the quote only if the exchange rate moves against them. If I pay for the quote, do I pay for 10 quotes to compare them? If I get a free quote and they say, look, we'll guarantee you this rate, but it'll probably be better. We're just protecting ourselves in case you wait for the exchange. Well, what if I get 10 quotes? Each one of them says it'll probably be actually better than that. How do I pick one? There's no way to solve this problem without extensive trust. And the problem with extensive trust is you can't build a global system that anyone can participate in if it requires point-to-point trust. Imagine if each email peering relationship had to be individually administered like with a legal contract or trust. Like that does not work. That does not scale. So the trick here is that trust element is eliminated. So if I'm making a $1,000 payment as a series of micropayments, if I'm getting a really good exchange rate, I could stream faster. If I'm getting a really terrible exchange rate, I could stream slower. And I don't need trust if I'm doing it 1,000th of a penny at a time. If you steal 1,000th of a penny from me, good on you. I'm just not going to send any more money your way. I'm going to send it the other way. And this iterates. So if I'm sending money to somebody, they might try 2 or 3 different paths themselves. And if they get a bad path, they might give a bad price back to me. But I'll still send a little money towards them because they may find a better path themselves. And when they do that, then I'll send more money to them to find that cheapest path. So kind of the same things that we do with routing today and multipath and VPNs, like you can do all those things with money in Interledger. There's going to be if I'm right about micropayments becoming like the thing, there's going to be a massive revolution in the way software interacts with money, and that's going to be a tremendous opportunity. That's going to be a whole new multi-billion-dollar industry. Over 1 billion micropayments were made last year just by web monetization. So the technology works today. It's not 100, there's a lot of stuff missing, just like the early days of the internet, but the opportunity is very clear. The money is routed through connectors. These protocols can connect digital assets with traditional systems seamlessly. They work just fine regardless of the underlying ledgers, just like IP can go over any lower layer. And this is an open standard, which is what we need. Like, you wouldn't want to integrate with the internet if every website used a completely different protocol, every data provider. There is a standard. There is a neutral standard that doesn't specify anything more than it has to. So the company that I work for, Ripple, has built an enterprise payment network on these principles. It consists of 3 products, one to process real-time payments, one is sort of like the browser to send the payments, and one to provide on-demand liquidity. Financial institutions use xCurrent to make and receive payments, xVia to initiate payments, and xRapid to provide cross-border liquidity. And this is a real network. This is a point-to-point network. It's not a central server like Swift or PayPal. This is a decentralized network where financial institutions interact with each other through protocols that are not centrally controlled. The biggest thing that we found, the biggest obstacle, was the legal environment. Enterprises are not ready for a trustless system that's proven by mathematical algorithms. They have customers who might get their credentials stolen. They might want to go to courts. One of the biggest things that we had to do to revolutionize enterprise payments was to come up with a set of rules so that like legal agreements could be negotiated with just a couple of red lines rather than a 40-page contract beginning to end of how to handle every possible failure. That doesn't go away yet. Hopefully the regulatory regime will get a little better, but on the enterprise side you have to have those kinds of agreements. So today, our customers use digital assets to settle payments immediately where that makes sense, and they use more conventional means where that makes sense, but they enjoy the benefits of end-to-end messaging, multi-hop, and the various things that an open standard can provide. We think that digital assets and interledger payments can build that internet of value. It's going to take the form of micropayments, probably in the sort of open world, because that's what eliminates that need for contractual agreements. If I can make a $1,000 payment as a series of fraction of a penny payments, then I don't need to worry about trust. I don't need to worry about legal agreements. I don't need to worry about dispute I'm not going to dispute a thousandth of a penny that disappeared. Thank you.